Now we're going to look at how we can improve our models through a process called feature engineering. And we've actually already started this process when we did some transformations in our simple linear regression models. But now we're going to generalize this for our multiple linear regression models. So here's a reminder of one of the types of transformations we walked through when we were looking at a simple linear regression model. And we saw that trying to transform data until it looks like it has a linear relationship, like here, and then fitting our linear regression model will usually lead in a better fit in our model. And it also allows us to fit nonlinear features, right? So at the end of the day, I'm able to fit a curve like this red one here that's not a line, but I was using the simple linear regression machinery underneath the hood because once I transformed this and this, the rest of it, in terms of what I threw into Python, looked like a line, right? It looked like some output, and then here's my slope and my intercept. And I can get the best slope and intercept and then transform back. So this is actually an example of what's called feature engineering, which is the process of transforming your features to try to get a better model. So this is an iterative process, this idea of feature engineering. There's not, a recipe that works every time. There's a lot of exploration in this process, but it will allow you to incorporate domain knowledge. So especially if you know something about the variables in particular and you have some understanding of, it would make sense to have this variable squared or the square root of this variable added into the model just based on your domain knowledge, this is a really great time to incorporate that into the model. And then, we're able to express nonlinear relationships still using the framework of simple linear models and or multiple linear regression models. And we're also going to look in the next video at how we can, as part of the feature engineering process, encode non-numeric features, some of our qualitative data, as inputs. So this will be covered in the next video. Right now, we're just going to focus on transformations for quantitative variables. So this is a reminder of one possible way to get started with your feature transformation. These are not hard and fast rules. There's multiple solutions. Some will fit better than the others. But again, you're looking for some general shape or trends. If your data is roughly shaped, kind of centered around this type of shape, then it may make sense to try a square root of the independent variable or the log of the independent variable or the square root of the dependent or the log of the dependent. And it's, again, a trial and error process. So this idea of taking the raw features that we have in our data and then transforming them somehow, we call that transformation process applying a feature function. So for example, if I had horsepower and miles per gallon in a data set, I could say, let me transform this, apply a feature function, and now I'm going to add horsepower and horsepower squared to my possible features to use in the model. So notice a lot of times when this happens, when we're applying feature functions, we're going to be adding new columns of data, but we're adding columns of transformed data. So it's not like I'm making up data. I'm taking data that already exists and doing some transformations. And then I can fit my model on these new columns. So designing feature functions is a major part of data science and machine learning. And in this class, we're just going to be doing it manually via trial and error so that you get some sense of what's underneath the hood in this process. But there is a whole field of deep learning where they have built some infrastructure where models have the ability to automatically learn feature functions. So if you're interested in that, I highly recommend you look further into the field of deep learning. So let's talk about some basic transformations, then we'll go to a demo with our model that we've been working with hybrid cars in the Jupyter Notebook. The first type of transformation that may come up is if you have features that are uninformative. So they really are not going to give you new information about your output variable. And if that's the case, usually your best bet is to just remove it so that you don't start having random variables in your model that are incorrectly influencing the output or leading you to what's called overfitting the data. So if you know based on domain knowledge or some basic understanding of the data that, you know what, this feature is probably not going to give me any useful information about what I'm trying to predict, then you can remove that, not include it in the model. Secondly, we have quantitative features that could be predictive, right? So age or acceleration in our car example. In those cases, we can apply some nonlinear transformations. And again, you can use that Tukey bulge diagram as a starting point, but a lot of this will be trial and error. Another way that we're going to look at transforming is to standardize the variables, and we will talk about this later when we show you how to do regularization. So for today, we're just going to practice applying a couple nonlinear transformations and then comparing it, see how it improves or changes our model. And then categorical features like state or the class of a car. These are things we're going to handle in the next video when we describe one-hot encoding. So for now, let's actually just pop back over to the notebook and let's look at trying some nonlinear transformations on our quantitative features and seeing how it affects our model. So as a reminder, we're in the OLS Jupyter notebook, and this is where we left off in terms of the model that we had created. And so now we're going to think of how we might want to transform either acceleration and or miles per gallon. And to do this, there's multiple ways you can try to decide what transformations to do. But one way that I like to start, I'm going to scroll back up to our scatter plots that we had of, here we go. So here was MSRP, this was acceleration, and this one was miles per gallon. And I want to just note a general trend that I see. So generally, yes, this was linear when I looked at MSRP. Here, let me get a little pen for us here. But more so than just a line, which is what we tried, I could say, well, what if we allow ability to have a little bit of this quadratic behavior happening, maybe something more like that. And so if I'm seeing more of a trend like that in the data, or at least that's at least when I'm eyeballing it, I'm saying, yeah, maybe I could see this being fit better by more of this shape curve. Well, then I could go to my Tukey bulge diagram and think of, if I have data that's slightly this shape or roughly this shape, what are some transformations I could do? And one possible transformation, if you go back to that diagram, would be to take your independent variable and square it. So let's say I am going to consider taking acceleration squared instead of just acceleration. So acceleration squared is something I'm going to consider. The other thing is, if you look at the miles per gallon plot, we fit it with a line, which I'm guessing was, I didn't even plot the line at the end because it was, actually, let me be clear. We put it into our model as a linear function, and then it was one of the features that we included, but we were thinking of it linearly. I can see here that there is a little bit more of this trend happening, right? And so if I go to my Tukey bulge diagram again, and I now look at this shape, one possible transformation I could do is to take the independent variable and square root it. So these were just two, by eyeballing it, I decided, why don't I add in an acceleration squared term and a square root of miles per gallon term, just because of the shape that I'm seeing in terms of how it's relating to MSRP. So if we go back here, let's scroll down. We're going to go all the way down now to feature engineering. And that's the form of the model that I've set up for us here. So I just wanted to give you some background as to how I chose that as a starting point. All that's going to happen is I need to add a column now that has acceleration squared, and I'm going to add a column that has the square root of miles per gallon. So that's here. And now you can see in my matrix that I now have added those two columns. So now for my linear model, I'm still going to initialize it. I'm calling it my 4-feature model because I'm going to keep acceleration in miles per gallon, but now I'm going to add acceleration squared and the square root of miles per gallon here. And then we're still predicting MSRP. So all of that is set up correctly. And then you can see the values that get fit. So here's my intercept. Here are the coefficients for those 4 predictors. And here's the actual predictions that are made, which I'm going to plug this right into here to calculate my RMSE. So just as a reminder, as a baseline, let's go up to the RMSE that we had in this previous model. We had, let's see, we were visualizing, there we go, 14,679, and our multiple R squared was 0.527. So we're going to try to get lower here and higher here. Okay, so now let's look at RMSE. Okay, we definitely got lower than 14,000, so this is improving. I'm doing our adjusted multiple R squared to account for the fact that I've added in 2 new features. And so this has still gone up, even with that penalization for adding 2 new features. The other thing I can do is look at my residuals and see if those have gotten more random. And so here's what they look like. And for comparison, let's do this. Let's look at all 3 models we've had so far. Simple linear regression, the 2-feature, and then the 4-feature. And I can see an improvement in the residuals here and the fact that this one's definitely looking like more of a random scatter. It's looking much more like it's kind of staying for the most part. These values are staying within this band for the most part. I don't have the same fanning out kind of thing that I was seeing happening here. So this is looking better, and there's still room for improvement, right? We're going to keep going with this process, but we're moving in the right direction is what we're noticing. And now I'm actually able to visualize this model again because I only used 2 features and their transformations. So this is unusual. You don't normally get to visualize like this, but I think it's pretty handy in this example to get to see how this model is going to look. Okay, and so now you're going to see that instead of our plane that we had before, we now have this curved surface because we're allowing for nonlinear fit, and it's capturing a lot more of the trend of the data, better than just our plane. So we're doing better. We're getting more improvements. In our next video, we're going to talk about how we can also add in information about qualitative features, for example, like the class of the car. And we'll see how that improves our model.